The identity matrix would be like what a 1 is in the matrix world. For example, the identity is what a 1 looks like in the matrix world. These are the way 1s look like in the matrix world. They don't look like this one here. They look like this. And notice that they change. This one's smaller, this one's bigger. But regardless, if you see this little number in here, this is saying this is a 2 by 2. This is a 3 by 3. Notice the main diagonal has 1s and the off diagonal elements have 0s. Main diagonal has 1s, off diagonal elements have a 0. And you could go on to I sub 4 and so forth. Now, if I were to multiply a matrix times its inverse, I should get the identity. This has the feeling of something like 2/3 times 3/2 equals 1. So this first one will be like matrix A, and this will be like matrix inverse A. And when you multiply these two numbers, you get a 1. So it's like saying reciprocal. A number times its reciprocal gives you 1. You could also say it like this. When you have an exponent of negative, that's like the reciprocal. So 1/2 is the same thing as 2 to the negative 1. So notice the 1s are coming up. A number and its reciprocal, except 0, will give you a 1 in the real number world. Now let's go to the matrix world. What do I have to multiply 3/5 by to get a 1? Well, you would say 5/3 will get you the one, the reciprocal. Okay, that's the real numbers. So these are not matrices yet. Now we're going to ask an equivalent question. What do I have to multiply this matrix to get the identity? Remember, the identity acts like a 1. So it's like saying, what's the reciprocal of this matrix? But we don't use the word reciprocal. It's analogous. We use the word inverse. So that little negative 1, instead of saying reciprocal, you're going to say inverse since you're working with matrices. Observe this. Okay, so these are the real numbers. These are not matrices. Notice how the matrices later on are going to act something like this. So suppose they ask you to solve 2x equals 3. Well, you know you have to get this 2 on this side. So you divide both sides by a 2. This cancels 2 or 1, leaves the x by itself. And now the 2 is on the other side. So x would equal 3/2. Or you could write the same thing using negative exponents. So it's 2 times 2 to the negative 1. That gives you the 1. But if you multiply this side by 2 to the negative 1, you have to multiply the other side times 2 to the negative 1. Then once you have it on the other side, then you simplify by taking the negative 1, but you flip this one around because this is like the reciprocal of 2, right? 1/2, which gives you 3/2. X equals 3/2. Now we're going to go with the matrices and try to remember what we did with the numbers. We're going to do more or less the same steps. Suppose A, X, and B were matrices. Solve for X. So we want that X by itself, so this A has to go to the other side. But with matrices, you don't have a division of matrices. It doesn't exist. So we're going to have to multiply both sides by the inverse of the matrix you want to move. If you want to move the A over to the other side, you're going to have to multiply it times its inverse. Why? Because after you multiply it, you get the identity, which will be like a 1 in the matrix world. So notice these cancel to like a 1 in a sense. 1 times x is x. And now we have the inverse of A on the other side. Why? Because if you multiply one side by the inverse of A, you have to multiply the other sides by the inverse of A. Keep in mind that matrix multiplication is order sensitive. So if I multiplied on the left, on this side of the equation, I have to multiply on the other side on the left of this matrix. So now we have this. The work's going to go to finding this. How are you going to find the inverse of A? And we'll show you. So we're going to find the inverse of A so we could use it. So here's the matrix A, is matrix B, and this matrix X. Notice that matrix X, capital X, is the one that's going to keep the variables. So it's A, X equals B. Here is the A, here is the X, and here's the B. So we need to get this matrix to the other side, but to do that, we have to multiply both sides by the inverse of this one here. So now we need to find the inverse of this one. It's already on the other side of the equation. How do you find the inverse of a 2 by 2 matrix? What you do is you copy the matrix and then put a bar and then put its corresponding identity. Corresponding identity means that if this is a 2 by 2, the identity should be a 2 by 2. So this is what we're going to do from here to the end. We're going to transform this side so it could look like this side. And then this side will become the inverse. So this will become the identity, and this will become the inverses. That's the one we keep. So how do you make this one look like this one? Well, you could multiply the first row by a -6, but make sure it's the whole row. And why was that convenient? Because now I could slide row 2 underneath, and notice when I add these two numbers, I get the 0 where I need it. And then you continue combining like terms. This is going to replace row 2. Notice we already put the 0 here. Now we're going to try to put a 0 here. So now multiply the whole row by 42. And you say, why 42? Because if you multiply the whole row by 42 and this one by 8, and you combine the column numbers, these two will cancel, and we'll put the 0 right here. So this whole row is going to replace row 1. This is going to be the new row 1. So we replace it. So notice how this is called an augmented matrix. It's changing. Now we need ones here and here. So what you do is just multiply this first row by the reciprocal of where you want the 1. So what's the reciprocal of 42? 1 over 42, multiply the whole row, not just the position you need, the whole row. And that gives you this. Notice now we have a 1 here and a 0 here. Multiply the second row by the reciprocal of -42. And when you're done with the multiplication, that puts the 1 here. Notice we've been able to transform this side of the augmented matrix into the identity. So if this has been transformed into the identity, this side is the inverse, and that's the one we need to use. So you put it where it was supposed to go. Here's the A inverse. So now from here on, it's just multiply the two matrices. Remember, it's a row times the column, row times the column. So it's the first one of the row times the first one of the column, the second of the row times the second one of the column. Now shift to the second row. The first of the row times the first of the column, the second of the row times the second of the column. That's this. Notice you add them after each multiplication. Now, if you combine all that together, you get these numbers. If you simplify this, you get these. Therefore, x equals 4, x equals 4, and y equals -4. And this is what we call the solution in matrix form, or individually as variables. This would be the x and this would be the y.